Hello, everyone, and welcome to Fusion Extensions, Customize, Automate, and Innovate. My name is Juliana, and I work in marketing here at MicroCAD. And today's presenter is Jose, our applications specialist. At today's webinar, we'll dive into the real-world applications that boost efficiency, reduce errors, and accelerate innovation. As usual, throughout the webinar, you can ask a question on the left-hand corner. You can ask Jose to revisit a step or ask any questions. This is your time, and we want you to make the most of it. And in the upper right-hand corner, you will find links to our social media, website, and YouTube channel. We post all of our webinars there at the end, so you can share with colleagues or watch it on your own time. You also have our LinkedIn link, I guess, so you can give it a click and give us a follow, and you're always updated with our latest news and events. And without further ado, I'll pass it on to Jose. Hi, Jose.
Hi, Juliana, and hi, everyone. Real glad to be here presenting this new, let's call it like version or entry on our series on Fusion Extensions. This one we called it Customize, Automate, Innovate. Basically because we wanted to make a focus on how Fusion can help us with these main topics, right? So we're not going to be talking about managing tools or simulation, those kind of things, analyze, but actually creating concepts, okay? So this is going to be all about how Fusion can help us get better results, how Fusion can boost our creativity, and how we can do all of that with some constraints in mind, how basically we can solve real-life engineering problems with Fusion, okay? So we can do all of this with, well, many of the extensions in Fusion, but we're going to be mainly talking about the simulation extension and the manufacturing extension, okay? Specifically, we're going to be focusing a lot on the generative design feature of Fusion that it's included with the simulation extension, right? And we're going to take a look at how all of those tools are kind of intertwined together so we can achieve better results, we can get more efficient products, and we can do that with, well, probably not just a couple clicks, but with a very, very straightforward process in our software, okay? So as you might know by now, we have 5 Fusion extensions available. We have the design extension, the managed extension, manufacturing, signal integrity, and the simulation extension, all right? The design extension opens up new tools for plastic design, for creating more complex parts that are very industry specific, right? The managed extension brings in new capabilities for managing product life cycle, creating life cycle guidelines, creating item numbers, specifying the life stage of your product. That is, if you're at development, if you're in production, basically all that's management related. All right. Manufacturing extension brings in tools for connecting to our actual machines in our shops, creating NC codes, creating codes for our 3D printers. For example, this is something that many people are not aware of. You can use Fusion for your 3D printing services. The signal integrity one, that's basically gonna let us do any electronic design work, that is, analyzing PCBs, analyzing signals, so it can be included in our product design as well. And the simulation extension, which on a side note, it's my favorite, I guess, for basically running simulations on finite element analysis and creating new concepts with our generative design tool. All right. So generative design basically means you're gonna tell the software what needs to be accomplished. Okay. So say, you know what, I need to transmit some force from this point to that point, right? I need to avoid this geometry. I need you to go through this from the location point A to point B, and I want you to do that as efficiently as possible. That is, as less material as I can, with the highest, well, probably not the highest, but with a threshold of safety factor, for example, or with as much rigidity as as you can. Okay, so generative design is going to let us explore design alternatives based on some rules, based on some restrictions, some constraints. All right. And the cool thing about how this tool was implemented is that now you can tell the software how you want to get to that part. Okay. So now it's not just about getting those kind of weird shapes that sometimes you get when you, if you're familiar with generative design, probably you've seen stuff that's very like organic, that some people don't like. They think, okay, that looks kind of weird, like out of an alien movie or something like that. I don't like that. Or maybe there are concerns of, okay, so this looks pretty nifty, very futuristic. How do I manufacture this? It cannot be done, right? So now Fusion allows us to look into all of that, to look into how I want to get to my part, how I can manufacture it as well. All right. And in that sense, this is going to go hand in hand with our manufacturing extension. All right. So when I generate a result and I need to go from the dream world that is CAD to reality, how can I get there? That is how I'm going to take that part, that solution that I'm getting right now, and I'm going to go into my CNC shop and I'm going to get the code for my manufacturing. If I want to mill the part, for example, right? Or if I want to 3D print the part, how can I do that? All right. So I think the best way to showcase all of that is to actually take a look at one problem. Okay. So one that I've seen and worked with in the past is robot grippers, right? This involves, well, as simple as it might look, it involves several steps or several issues, let's put it like that, in the sense that it can get as simple or as complex as you want. Okay, and the issue with our grippers is that they need to be able to grab the part with a certain force, right? And with robot design, you always want to look out for the obstacles. You always want to look out for everything that might get in your way on the path, basically. Okay. So we're gonna attempt. Yeah, we're gonna try to create a solution for an defector, right? And this is gonna be something out of my own imagination, if that makes sense. So that is, I'm not taking an example of one of the example files, like a tutorial or anything like that. No, I just went on. I imagined that I actually needed to build this in real life. Okay, so basically, how it started was, okay, I'm going to define the geometry that I need to get to. Okay, so I already know how generative design works, so I started by defining the geometry that I need for my design. All right, so first of all, I specified what would be my plate for the manufacturer, right? Where I'm going to attach to my robot, right? And then I need to tell the software, okay, I want to be able to grab something all the way down here. Okay, so this is going to be the region that's going to support the force, or where I'm going to assume I'm going to be gripping the part. Okay, Remember, this can get as simple or as complex as you want to. I'm gonna try to keep it real simple, okay? So what I'm proposing here for this showcase is I need to create something, create a part that needs to transmit or that needs material from this end vector all the way to this portion, like the finger of the robot grip, right? But the thing is, I need to be able to do that without crossing any of this red region right here, okay? So this red region is gonna be my obstacle, right? I need to create material that goes all the way over there that supports a certain amount of force that I'm gonna apply over here, right? And that avoids this geometry right here, right? Just so you're aware, in generative design, it's always a good idea to start with kind of like a solution of the sorts. That is how you'd expect your solution is going to look. Okay, that is going to let the software. That's going to help the software a little bit in the sense that it's going to start exploring for solutions from this point. Okay, remember when we're talking about this kind of tools in Fusion. We're talking about machine learning. We're talking about deep learning. We're talking about artificial intelligence on the works. Okay, so this is what it's all about. How these new technologies, these new tools can help us. Okay, so basically, what we're going to do is we're going to let the software do its thing. That is, explore the solutions from a starting point, right? Doing the analysis, doing basically what. Basically explore design solutions to see if they are going to work or not, and start learning how the shape should look. That's basically what generative design does. It's an exploration. It's looking around in the dark, but with a lantern. This is the lantern I'm giving the software. Okay, so this is what I need to define, basically. So I got. There we go. Got my, oops, started like this, there we go. All right, I got my attaching plate right here, okay. I got the location for the gripping part. I got my obstacle geometry, and I got this with, that it basically would be with my starting point for exploration, all right? Notice too that I'm not creating the whole grip. That is, I'm not creating the whole claw, like the lobster claw, if that makes any sense, right? Because what I'm expecting is everything's gonna be very symmetric, right? So for now, I'm just gonna simulate half of it. It's gonna be easier that way. And besides that, I'm gonna add some new restrictions, okay? So first thing I'm going to do is I'm going to move to my generative design environment, right? As soon as I do that, I will be prompted to select the type of analysis that I want to create, study, sorry, that I want to create. A structural component one, a fluid path one. In this case, this is going to be a structural component one. Okay. Now this is going to be created automatically. And now I need to tell the software what are my objectives. Okay, so same as it always has been on Autodesk. You want to go left to right. May just make sure that everything is filled in properly, right? So I got my study already set. Okay, I can check the study settings. I'm not going to move any of those. If I need to, I can edit my model, right? For example, if there's say a round or fillet or something that might give me a lot of trouble, something like that, I can clean up my model, simplify it a little bit. So, for example, I can get rid of these holes right here, for example. Well, actually, these ones are not going to make any difference. But let me. All right, already did that. Okay. So basically, I got rid of the faces of this attaching plate, right? I need to remember, always remember, that what I've been doing so far. So if I get a solution for which I need that space, I need to consider that. All right. So no, chances are that I'm not gonna get a right solution that looks well like this, right? Because I need to account for these kind of things. So it's always a good idea to check on the work, basically check on what you do, right? Now I'm gonna set all my design space. I'm gonna specify what I need to preserve and what I need to avoid, right? So preserve geometry, I need to preserve this, I need to preserve that, right? Obstacle geometry, what I want to avoid. I want to avoid sorry about that. Model. There we go. There it is now. That's right. This is my preserved geometry. Geometry to avoid, basically, it's going to be this one. Right? And now I want to specify my starting shape. I'm going to start exploring, right? I'm going to specify that from this shape, I can either add or remove material. For example, the remove material tool is very useful if you're planning on manufacturing this, that is, you're starting from stock or something like that, and you only need to remove material, right? So I'm going to leave it like this, just to explore the kind of solutions that I can get. And now I'm going to specify a symmetry plane, okay? So I already said that the clamp is going to be symmetric in this orientation, right? But if I model the whole thing, I can also specify that the design should be symmetric around this plane right here, okay? So you can work with it in several different ways, depending on how you need to apply your force, on how you can model your geometry, how complex it is. You got both options. You can model certain portion of it. You can specify symmetry planes, all those kind of things, right? So I'm going to specify my origin plane. This one is going to be my symmetry plane, right? Now I want to specify my design conditions. In this case, I can review what's been done here. Preserve geometry, obstacle geometry. I'm going to hide that, hide the sorting shape, and I'm going to specify how I want to constrain this little plant here. So I'm going to specify a fixed constraint for the end vector, right? If there's someone watching that knows FEA, they might think, okay, but that's probably not the better way of specifying your symmetric constraints here. No biggie. You can always specify the types of other types of constraints. You can specify the directions for your constraints as well, and you can specify even other types of constraints like a pin constraint, friction, remote constraints, those kind of things. Okay, so in any case, you can make this model as simple or as complex as you want, and run different types of scenarios, right? Remember, you can always create new generative design studies where you can specify different constraints, different loads, different cases, right? In this case, I'm going to specify a structural load, a force that's going to act in this direction. That's going to be 50 newtons, right? And now what I need to define is the design criteria that I need for my problem. That is what I'm aiming for and how I want to get there, okay? So the objectives might be minimize mass, that is as least material as possible, right? Or I can maximize the stiffness, okay? I can specify a safety factor, a minimum safety factor that I want for my part as well. And if I maximize stiffness, that is, I want the part to move or deform as less as possible under those circumstances, I can specify a mass target to. In this case, I'm going to set this to minimize mass. If you want to do something a little more advanced, for example, if you're worried about resonance on the model, you can specify a minimum first mode frequency, so you can avoid dealing with we don't want that frequencies of force or movement in your model, right? You can specify displacements, maximum displacements in the three directions, right? And if you want to avoid buckling, you can do that as well if you're planning on creating structures, those kind of things, right? I'm going to keep it simple for now. I didn't hit OK. There we go. Okay. And now we are going to tell software how we want to actually manufacture this thing, right? So I can set this as unrestricted, right? Which is basically going to find any path, like a neurological path, whatever thing, crazy yelling kind of thing, that's going to get me from point A to point B in the most efficient way as possible, okay? But how this is going to happen might be something that came out of science fiction, right? So you always want to check one of the manufacturing options that we got right here. I'm going to set these ones as additive, right? And I'm going to set milling as well. I want to explore both options. I can tell the software how I want to make that the additive manufacturing, that is the orientation for my extruder, right? And I can specify an maximum overhang angle for the 3D printer guys are there. You might know that's usually 45 degrees, and the minimum thickness as well. Okay, I can explore different directions if I want to, and I can also configure milling solution. Explore how I can manufacture this using just milling machine. Okay, so in this case. Rid of that. In this case, I'm going to specify that I'm going to use a 3-axis machine, right? I could specify 5-axis or 2.5 if I want to as well. And I can specify what's the tool direction for that configuration, okay? If I want to explore even more options, I can just include all directions. So the software can basically explore solutions in all the ways, not just the C minus direction. C minus being, well, against this C-axis, right? But basically from all directions. But the more you ask of the software, the more the time it's going to take for me to obtain a solution, right? Can specify the minimum tool diameter, tool shoulder. I can specify 2-axis cutting. I can specify if I want to create this by casting, right? So I got many options that the software is going to explore. And as soon as I tell the software how I'm going to manufacture this, I can tell which materials I want the software to explore. Okay. So say for additive manufacturing, I want you to analyze with aluminum. And let's see, I'm going to explore with plastics as well. Right, so nylon plastic, yeah, sounds doable. Let's see what we get. For our milling operations, we're going to use 6061 aluminum. And let's see, I can explore too with metals. Actually, I'm not going to explore any more metals because any other one might be a little too expensive, right? So I'm going to explore with plastic, probably with ABS, right? Or nylon as well, right? So with software, it's gonna look into possible solutions with all of those materials, and it's gonna explore the solutions, all right? And now it's all a matter of Yeah, there we go. Right, so I can start by generating a small preview on how this might look, right? So the software is going to start from here, and it's going to eventually create a shape that's very, very close to this. All right. In this case, I'm going to stop the preview. And when I'm ready to send this to analysis, I can hit generate. All right. Now, at this point is where Fusion is going to check if you actually have access to the extension or not, right? So if you're planning on getting the extension and activating it, the extension active check mark should be set here. Or if you're using tokens, that is with Flex in Fusion, here is where those tokens are going to be charged, okay? So when you hit generate study, sorry, little time bar will activate here, letting you know the percentage of analysis that has been run. In this case, a generative design study takes long, well, not like days or something like that, but it takes quite some time because it needs to produce millions of possible solutions, analyze each one of those with them, analyze the stress that you're getting, and start discarding the ones that are not going to work, keeping the ones that do, and start making modifications over and over and over and over again. So that's why you require AI to do these kind of things. All right. So when you hit generate what study, you're gonna sit back, keep working. You can't even keep working in Fusion, right? This is gonna just be added to your job status, right? On generative designs, this will appear in here, right? And you can close the job status window and keep working in Fusion. Go get back for a little while, take a cup of coffee, come back. Depending on the complexity of your project, it might take 1 hour, 2 hours, I don't know, depends. But by the end, you're gonna get something like this. You're gonna get a little check mark right here, and you're gonna get the Explore Generative Results button, okay? So when we click on it, this is going to take us to the fun part of checking the results in Fusion. This is going to let us look at all the possible ideas, explore the ideas that we got here, and basically make a decision. All right. So all of these are the results that Fusion was able to come up with, right? Based on the requirements that you specified, right? So for example, I get study one, this little option right here. This one was set with aluminum, right? And it's a non-restricted one. This is one of the alien kind of solutions that I told you about earlier, right? Looks very, very organic, right? But it's at the least amount of material that you can get to get from point A to point B, right? While avoiding what you need to avoid. Okay? You know what? This sounds kind of cool for the latest Guardians of the Galaxy movie, but it's not feasible in real life. Okay, so let's clear. Let's add some filters then. I'm gonna clear the unrestricted, and I'm gonna take a look at the additive options. All right. So, for example, I got option number 5. All right. So it's not as crazy as the other one. It makes a little more sense, right? But saying it's using very, very little material to get from point A to point B, and assuring that you're within the safety factor limit. Okay? In this case, the minimum safety factor limit is 7.71. I get a mass of 0.073 kilograms. That's 73 grams. So that's pretty good. And this was done in aluminum. All right. This is supposed to be 3D printed. So I can tell for sure that I can actually manufacture this part. All right. Say, yeah, I want to explore a solution that's not additive. What if I wanted to 3D mill this thing? Okay. So, for example, this outcome. So it requires a lot more material, right? but at least I know that I can manufacture it from the Z-axis, okay? In case I need to start with a block like this, and all I got in my shop is a 3-axis machine, right? Probably thinking, okay, probably would be a better idea if I try to do this from this orientation. That's for the Y direction, right? So that would be that would be something that or why you might want to explore different solutions and different orientations from your original setup. Okay, so when you set up the manufacturing options, you would set, okay, I want to explore the tool direction from the Y-axis as well, right? But as I said before, the more options you explore, the longer it's going to take. But you might find a very decent solution. Chances are too that you might want to check how the solutions compare to each other, right? So you can do that as well. You're going to go to the scatter plot view, right? And we'll be able to see all the possible solutions, right? In the materials that I get, and I can check objectives against each other. For example, mass against the minimum safety factor, right? So for example, for this solution right here, I got a safety factor of 2, right? I'm gonna click on it, so it's fixed right here. Get a minimum safety factor of 2 with the least amount of mass possible, okay? But if maybe I decide, okay, 2, it's a little, it's too little. Maybe I'm gonna explore another solution. Okay, so let's take a look at this one, right? So this one is, it's a little more heavier, right? But it has a better safety factor. We're talking about 30 as our safety factor here, right? But in this case, remember, this one is an unrestricted one. So I might get into trouble trying to manufacture this in real life. Maybe I can explore this other solution, outcome 5. This is the one that we saw before, right? Minimum safety factor of 7.71, the mass 0.073. Looks kind of nice, right? So it's not about just selecting, okay, which one has the least safety factor. Okay, so that's it. That's my solution. No, remember, Fusion is going to present the information to you, and it's going to give you all the tools so you can make an informed decision. But the decision is up to you, all right? So in this case, I can go ahead and select this one. For example, as the solution I want to be working with. All right. So the outcomes that I get from my generative design tool can be exported. They can export it as a mesh design. They can export it as a regular design. Okay. So when you do that, you will get something like this. If I click here, it's again, it's gonna take a little time, right? It's gonna go to the job status, but by the end, you're gonna get something like this. Okay, so this is another result that I exported, right? Just because I think it looked cooler in the sense that it gave me the option to be a little more flexible with the gripper, right? So by the end, what I'm gonna get is this solution right here, or this model right here. Okay, this is gonna be your regular Fusion design, right? And basically, you can do whatever you want with it. Okay, let me just close this preview window. The view. Here we go. And well, from here, the cool thing is you have everything set in one single environment, right? So now if you want to go ahead and make some changes to this design, which by the way was supposed to be like this originally, right? Some portions of the design were left with some sorry, we're left with some material over here. So I can do a little cleanup basically modify them all to however I see fit, right? I can add the holes if I wanted to, or maybe move them if that doesn't seem right or whatever, right? Or I can even modify the design so it actually achieves what I need. Remember, this is supposed to be a gripper, so this is supposed to be like the finger of the grip. And right now, what I have is just a support. It's a single piece, right? Maybe what I need is to create a little mechanism that goes right there, right? So basically, I can use this design to actually get to my the result that I actually need. All right. Sorry about that. But let's suppose the part that I want to print is this one. Okay, so we're not going to spend some time dealing with regular design, creating this as a separate part. That's basically your regular Fusion design things. Okay, we're going to jump to our manufacturing. Okay, so the good thing. Oh, but before I do that, I'm gonna clean this one up a little bit, right? And add some features here that are gonna make it look a little nicer, right? So gonna add some fillets and such. And I'm gonna suppose I wanna send this to manufacturing, right? So the good thing about those constraints that I put in place is that I know for a fact that this can be 3D printed. Okay, I'm not gonna get into trouble trying to create the supports, trying to figure out if the filament is or if the sections of the part are too small for 3D printing, anything like that. Okay, I know for a fact because that's something I set up as a constraint. All right, so from here it's just a matter of setting up my manufacturer. Okay, so this is why the webinar is called. Let me pull it in again. There we go. Customize, automate, innovate. Okay, because we are creating new parts, we're innovating, we're creating new solutions, we're customizing the solutions that I get, and everything in the process is done automatically. Okay, so everything is placed on one single platform, and everything can go in one single workflow or one single stream. Okay, so I'm gonna set my manufacturing here. I'm gonna set this as additive. Gonna manufacture this body, so I'm gonna 3D print this in my all reliable home 3D printer, like Reality Ender 3 Pro. All right, and I'm not gonna make any arrangements. I'm just gonna set up my part in here. The way right here, chances are that the best orientation for my part is this one. There we go. Center it a little bit better. There we go. We're gonna set this one up. Lay bobbin tube. Okay, for my preset, I'm gonna set my infill not to 25. I'm gonna set it to 85. I want it to be very, very rigid. I want to specify a honeycomb infill pattern. I want to specify print bed adhesion, basically you name it. Okay. So as I mentioned before, not many people are aware of this, but you can also 3D print stuff from Fusion directly. Okay, so you can export to slice of software if you get a high-end printer, for example, if you have a Formulabs printer or something. Well, let's think of a Formulabs one. Fusion is going to give you the option of exporting those to their dedicated software. So it's very, very neat as well. But if you're like me and you like creating homemade projects, you like messing around at your home, well, you get that option as well. All right. So you can do slicing, you can create supports here, right? Overhang at 45 degrees. I don't want to avoid anything. Gonna hit OK. Give a second for it to create. All right. And now I can generate my toolpath. Here we go. 3D time, 3 hours, not as long as I'd expect, probably because it's not that high, right? Let's see, simulate out. I take the toolpath just to check that everything looks right. And there we go. We got our honeycomb structure. And that's how it's done. All right. So I can go ahead and post-process this, export my my G code in this case for my 3D printer, and everything goes in one single stream. All right. Now, if I want to explore other solutions, for example, say I want to explore a solution for a milled part, right? I can do that as well, of course. It's just a matter of specifying the same thing, exporting the design, getting the design, and starting that manufacturing model so I can set up it properly. All right. So I get my setup here with Tormac machine, which is basically a 3-axis machine. I specify my setup with my stock, starting from a fixed size stock of 150 millimeters by 50 with a height of 60 millimeters, right? And for my setup, basically, I'm just gonna, well, for now, I'm just showing the machine right here, but I'm not gonna get a lot into all the, or how we can set up the manufacture of the part right now, okay? Because that's a whole class, a whole webinar series that is gonna let you know how we can do this, okay? But the point here is we can make use of these tools from the manufacturing extension as well. And so you get one single stream, and you can make use of the other intelligent, I guess the best word is intelligent, of the intelligent tools we get here in Fusion. For example, adaptive clearing, right? Basically, for obtaining the tool path for clearing the material from this for this part as best as it can, right? So I got all my tool path to set my shape free. All right. So everything is set in one single software in one single location. You can make use of all of those tools and get better results, be more efficient in your job, and be more creative as well. All right, I think that's what I wanted to show you guys today. I don't know if there are any questions.
Thank you, Jose, for that wonderful presentation. It was really, really cool. Let me check if we have any questions. Okay. Can you link the generative design tool with any manufacturing setup type from the manufacturing extension?
All right. So basically, it depends on what you mean. That is, if you're working on the generative design tool, you got options for analyzing the tool in an additive direct using additive manufacturing, using milling, using 2D axis cutting, or using casting, right? And from milling, you can set 2.5, you can set 3, and you can set 5, right? So if we're talking about turning, for example, or if we're talking about some more tools like that, there's not that option yet on the generative design. Okay. Nevertheless, remember all of this is part of one single design. Okay. So if you're getting one solution from a manufacturing option, right, and you want to send that to manufacturing and use a different one, set it up in a different way, you can do that as well. Okay. You always have the option to go into your design, modify the design to fit your needs, to adjust to the manufacturing option that you need from the manufacturing extension. So you still have that option.
Great, thank you. And also, if you want to learn any of these topics in detail, you can take a custom training with Jose or someone else on our team. And we also offer group classes online. So, yeah, we highly encourage you to check our, I think it's on the right hand, you have the webinars registration page. Give it a look, and if you find any of them interesting, you can just register, and even if you cannot make it, you will get the on-demand recording. So for example, next week we'll have on January 22nd at 1 p.m. the role of digital twins in modern AEC, and on January 23rd we'll have Simplify and Succeed with Civil 3D and Autodesk Docs integration. So yeah, we wanted to uh, give you the thanks for being here today. And as usual, you will receive the on-demand recording for this webinar tomorrow at 1 p.m. You can also contact us by replying to that email, and we'll get you up and running. So yeah, thank you everyone for attending. Thank you, Jose, for that great presentation. And see you on the next webinar. Thank you.
Okay. Thank you, Juli. And thank you, everyone. Hope to see you in the future. Bye bye.
Bye bye.